All right, this is practice and corrections for your mini math star for you guys that are doing on-level math. Okay, it says the volume of a cylinder is 87.35 cubic inches and the radius is 5.17 inches. Okay. Which equation can be used to find h, the height of the cylinder in inches? Okay, so first of all, I'm going to take a second and I'm going to look at my formula chart. I'm going to go down to volume right here. Volume of a cylinder is capital B times H. So that's the first thing I'm going to do is I'm going to write that down. Volume equals capital B times H. Now, remember that the capital B stands for the area of whatever base we have. Now, if you are thinking about a cylinder looks something like this, and the area of its base is a circle, okay? And the radius of that circle is 5.17 inches. Okay, so really, in order to find the volume, I need to put area of a circular base into this formula. So I'm going to rewrite that. Volume equals, what am I going to put for the capital B? The area of a circular base. So I need area of a circle. Here's circle area right here, pi r squared. So instead of writing capital B, I'm going to write pi r squared because that is the area of my base and my base is a circle, and then times h. Okay, and it says write the equation used to find height. So all of this is multiplied together. Basically, it's pi times r times h, or pi r squared times h. If I want to leave h by itself and move everything else, well, all three of these things are multiplied together. So I'm going to divide by the two that I want to move, which is pi and r squared. But if I divide over here by pi r squared, I have to divide over here by pi r squared as well. That gets rid of that. Rewrite it. H equals volume over pi r squared. Now, the only other thing I have to do is figure out where the numbers that they gave me are going to go. Volume is 87.35, so it's going to go up here. Divided by pi times radius, 5.17 squared. And then I go shopping for an answer, and that's going to be answer choice D. Okay, let's move on to number 2. Josh is saving money to buy a computer. He put the initial amount he has saved into a jar. Each month, he puts an additional amount of money into the jar. The table shows the linear relationship between the number of months Josh has added money to the jar, X, and the total amount of money in the jar, Y. Okay, so even without a whole lot of numbers, here's the situation. He has saved for a certain number of months, and he's got money in the bank. Now, at the beginning, he put a certain amount in the bank, his initial amount. Okay, we don't know what that is, but that's at time is 0 months, okay? And then, like at 5 months, he had $225. And at 7 months, he had $285. And at 11 months, he had $405. And at 15 months, way over here, he had whatever, okay? So it creates this linear graph. Okay, we don't know the initial amount, but what are some of the things that we can figure out? We can actually work backwards and figure the initial amount, but not quite yet. The first thing I probably am going to do is I'm going to figure out how much he's putting in the jar each month. That's the rate of change. Like from 0 to 1, you know, how much does that increase his money? Basically, what I'm doing is I'm going to find the slope. And remember, slope tells you the rate of change. Here's your formula. y2 minus y1 over x2 minus x1. I'm going to pick, it doesn't matter which pair of points you pick, but I'm going to pick the first and the last. So 525 minus y1, 225, over 15 minus 5. Okay. 525 minus 225 is 300. Divided by 15 minus 5 is 10. 300 divided by 10, my slope is going to be 30. Next, I can actually figure out what my starting amount is if I will do this. Take y equals mx plus b. This is your equation for a line in slope-intercept form. I have figured out the slope. So 30 is going to go right there. And then it really doesn't matter which point. Just pick a point and put in the x and y value. Okay. I'll just pick this first point. Okay. The y value is 225. So that's going to go there. Equals my slope, 30, times my x value. Oops, let me pull this up a little bit. My x value is 5 plus b. Okay, b is my y-intercept. It would be my starting amount. Okay, here we go. Get this zoomed out a little bit so you can see everything. Okay, 30 times 5 is 150 plus b equals 225. To get b, just subtract 150 from both sides. 225 minus 150, 75. Okay, so the initial amount, the y-intercept, was $75. The initial amount Josh put in was $75. That is correct. Okay, but let's look at the other ones. The initial amount Josh put in the jar was $225. No. That might be tempting, but that's just the first y value in the table, but it doesn't go with 0 months. It goes with 5 months. So that's not going to be the right answer. The amount of money Josh adds to the jar each month is 45. No, that's the slope, and we determined that he puts $30 a month in. All right, and then the last answer choice says the amount of money Josh is adding to the jar each month is 60. No, he's adding $30 a month. So we're going to go with answer choice B. But what I did, again, is I used the slope, and then once I had the slope, I just used the slope and picked one of the points, it doesn't matter which, to determine my y-intercept, and then I've got my whole thing. All right? All right, number 3, the table describes 2 dilations with the center of dilation at the origin. Which rule describes each dilation? Move the correct answer to the box below. Not all answers will be used. Okay, so just visually, I put a triangle and a square on a coordinate grid. If I take this triangle and shrink down, dilated by a scale factor of 1/2, so now this side is only half as long, and this side is only half as long. And so when you dilate it down by a scale factor, you get a new triangle, which is a lot smaller. So I'm only going half as far, I'm only going up half as far, etc. So I'm going to take my x values that I had originally, like let's just say that this was an x value of 6. This new one's going to be half of that, an x value of 3. So you're going to take this, multiply it by 1/2, to get 3. Take this original, multiply it by 1/2 to get this new one. Okay, so rule x comma y is going to give you 1/2 x comma 1/2 y. All right, a square is dilated by a scale factor of 2. So I'm going to take this and stretch it out, and I have this new square, which maybe this is 2, -2, and maybe this is -4, something like that. So what I've done is I've taken my original and I've multiplied it by 2 to get my new. So that one's going to be this one, x comma y to 2x 2y. Okay. All right, number 4 says which mapping represents y as a function of x. Okay, if it's a function, first of all, and you have, points or whatever, it's got to pass the vertical line test. In other words, you can't have a single x value with 2 different y values. You can't have y values repeating for the same x. So here's an x that generates 2 different y values. That's a no function. Here, this x generates 2 different y values. That can't happen. Let's look at the other choices. Please make sure to write this down too. If it's a function, you have to have a different y for each x, and x cannot generate 2 different y's. Let's look at the other ones. Here, this x generates 2 different y's. This x generates 2 different y's. That's a no. Okay, this x generates this y. 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 You don't have any x values that are generating 2 different y values, okay? This x is only generating 1. This one is generating this. This one is generating this. This one is generating this. In other words, if you graphed this, -1.5 and 1.5 would be like here. -1 and 1 would be like here. -0.5 and 1 would be here. 0.5 and 1.5 would be here. It's kind of a funny looking function, but it would pass the vertical line test. So this is your only one that's a function. Okay?